Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, CubeSandbox, a lightweight sandbox built for the new era of AI agents. As autonomous agents become more powerful, the need for a secure, high-performance environment to run them is critical. This Rust-based project provides just that, offering an instant and concurrent solution to safely test and deploy your AI creations. How do you let an AI run code on your systems without risking a major security breach? The usual answer, a virtual machine, is just too slow for modern apps. A new project is here to solve that exact problem. It offers true hardware-level security, launching a fully isolated environment in less than 60 milliseconds. This project is called CubeSandbox, and it's an open-source sandbox service from Tencent Cloud. It was engineered for a very specific purpose, to give AI agents an instant, secure, and lightweight environment for executing untrusted, machine-generated code. And it seems developers are paying close attention. The project is gaining serious traction on GitHub, with over 9,300 stars and an incredible 476 of those added in just one day. That kind of rapid growth shows just how much demand there is for a solution like this. The core problem here really comes from the rise of AI agents. These agents, which are powered by large language models, often need to write and run their own code to get things done. But that code is inherently unpredictable and untrusted. Running it directly on a system is a huge security risk. The conventional ways of handling this are flawed. For example, Docker containers share the host system's kernel, which can leave a door open for sophisticated attacks. On the other hand, full virtual machines provide strong isolation, but they are far too slow to start up and eat up too many resources. This makes them impractical for the high concurrency, low latency needs of today's AI applications. CubeSandbox directly addresses this conflict between weak isolation and poor performance. So, how does it work under the hood? CubeSandbox is built on a micro-VM architecture, using technologies like RustVMM and KVM. A good way to think about it is giving each task its own tiny disposable computer, instead of just a separate room in a shared building. Every sandbox gets its own dedicated guest OS kernel, which achieves true hardware-level isolation. Let's break down three key technical aspects. First, there's the speed. Its sub-60 millisecond boot time is possible thanks to a highly stripped-down Linux kernel and a high-performance shared file system called virtualization. This setup avoids copying large disk images at startup. Second is network security. This is managed by a component called KubeVS, which is a virtual switch built with eBPF technology. This means network policies are enforced deep inside the Linux kernel itself, making them incredibly fast and impossible for the sandboxed code to bypass. Third, there's a custom snapshot engine named KubeCodeW, which stands for Copy on Write. This engine can save the complete state of a running sandbox in milliseconds, allowing for instant cloning, debugging, and state rollback, all of which are critical for developing reliable AI agents. So, who is actually using this? The primary users are, of course, developers building AI applications that need to safely execute code from large language models. But the use cases don't stop there. Online education platforms can use it to create secure environments for coding exercises and automated grading. Software testing teams can use its fast startup and snapshot features to create clean, isolated environments for every single automated test. Security researchers also benefit, using it to analyze potentially malicious software in a space that's completely walled off from their host systems. And getting started is designed to be straightforward. The project is natively compatible with the E2B SDK, so migration can be as simple as changing an environment variable. What's the word from the developer community? The discussion is broadly positive. Developers are praising the unique combination of hardware-level isolation and near-instant startup speeds. The fact that it's open source and self-hostable is also seen as a powerful alternative to commercial cloud sandbox services. But of course, it's not perfect. Some concerns have been raised. The technology does have a steeper learning curve, and it requires some familiarity with KVM virtualization to get the best performance. Also, its ecosystem is still maturing. Now, to be objective, the project's complexity does present a challenge. Its architecture brings together multiple advanced technologies, which naturally raises the bar for maintenance and troubleshooting. The system's deep reliance on Linux KVM and eBPF also limits its portability. It's not something you can easily move to other operating systems or virtualization platforms. Furthermore, there's a feature called the Credential Vault. While it's convenient for managing API keys, it also centralizes risk. A compromise of this single component could expose all the secrets that pass through it, making the security of the vault itself absolutely critical. In the end, CubeSandbox delivers a finely tuned balance between the robust security of virtual machines and the speed of containers. It represents a truly critical piece of infrastructure for the AI era. This is the kind of technology that enables developers to build and deploy the next generation of autonomous software agents, doing so safely and at a massive scale.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.